And here you're talking about, you have three things. One is called a storage repository, contains all experimental data, data and metadata, data management. And then you contain with analytic platforms, with methods and with profiles, and at the end of the day, you have to put out the results. So this is the three things we have to build. And it's geared together, as Chris said, we have to integrate it in a way. And then we concrete it. So we still have to align with what we proposed. So basically we'll see there are three components here. One we have to build, including the extending this concept of each scientific storage system to so-called each study repository. Right? This is the really force data standard, and then have a system to enforce the implementation, the use of the standard to store the data in a standard way. So therefore, you have a comparable, now we call it fair, findable, accessible, interchangeable, reusable. I hope I'm right. So the kind of data environment. And then, because of data standard, so the curation will become easy. Now you can load into the Transmart, and we already foresee at the time the Transmart is not really ready to deal with a very complex and very computationally intensive job. So we talk about we have our cloud, and then we still have to store it in with some knowledge representation. So that was the 2014, in the middle of the project. And then we really think there are a lot of the options here. So we argued a lot about it, and not really argued, debate, or discussion. Say, who are our users? And what is the architecture we should take? And what is the data model? And what the data standard should we support? And what technology we should adopt? So this kind of debate. But this is not only for the Transmart, but also for all the system. But because you cannot really say either. For example, the Transmart, it's a Transmart designed for whom? For bioinformatician, people agree. But is that really for clinician? Probably not. But it's certainly not very fit for a data manager. So it's definitely have something. For example, in the Transmart, you actually have the workflow users. People can use the existing workflow. But what about the workflow builders? People who write the code. It's not inside of Transmart. So this is a lot of discussion going on. So, and also we're talking a lot of things about architecture. So, and should we make a system be plug-in, a service-based, or should it be a really data warehouse? And also have a component model, what kind of thing we should adopt. And, come to data model, even security have a lot of choice. And then you come to with the data model, it's RTB2 based only. So what about the others? For example, when we integrate this XNet, you will have a quite different way to access the clinical information. So, and what is the way we can think about to extend the data model? And should we extend a super data model, or should we allow the different data model to interact? And also a data standard, right? See this by default, we have to support. It's very nice, but what about the others? So now we will have a big European project probably in the future called verification, where deal with many, many different data standard, and which technology we should support. This is a big problem, right? Because when the time goes by, the technology come out. So Transmart developed in 2007. A lot of technology is pretty old. So what about this new technology? Should we adopt it? So that's why we come to the middle review, right? Each middle review. And we give this idea, and when I did the review time when I was in Brussels, and give the concept of each as a service. So basically we're talking about is, we have some kind of service bus, and we can really have the freedom to developing a different kind of components and different systems, and use it as service and make it intact. So this is actually quite a modern view in IT and every single service. So that is the design, the concept, the idea. So it's really, this time, we actually want a system to allow the exploration, right, rather than try to converge. So we were saying, great idea, try to integrate, for example, a big data, a storage-based Transmart instance. It's a great idea to try image services. I don't know how actually will be put together, but let's have a try. And then we were thinking about port data management services and developing, this is the sort of birth time of the EHS. So that is the kind of work. So the rationale of this explosion is this. So we're actually quite convinced it's hard, if it's not possible, to develop a single data platform for everyone, for everything. It's very difficult, and if it's not impossible, right? And Transmart is designed for data analysis, and very nicely, and still have a very ambitious goal to achieve. But it's not really designed for normal data management, right? And if we're talking about the data management community, talking about the open fact, talking about the people working on the semantic databases, talking people working on the data repository, and Transmart is something you consume those data rather than use to organize those data. So therefore, when you think about it, we need a flexible data management system to organize the data based on a Docker standard. So analysis needs the data to be rigid. Management needs data to be flexible, but based on the standard. So that's a big difference here. So for this reason, in 2014, we started the journey at EHS, which Ibrahim will present in detail, and we already have a system fully functioning. So Transmart designed for, I wouldn't use the word simple analysis, that's probably too routine analysis, for example, but not really designed for complex, right? Online coding, for intensive analytical, even for machine learning. So that kind of job, we have to provide support, and we foresee, right, not in the future, even now, machine learning play a very important role in analysis, and this is not something Transmart actually designed and should look for. So we need something to support it. Of course, we have a big task of result management, which is go beyond just the data and come to the point of the disease map and the really knowledge representation. So that's the rationale. But at the same time, and we have to realize technology evolved, right? We use probably the technology developed at that time, right? Like Grails, like Zen for actually virtual machine, SQL, all these things. But now, if you look at the line in memory processing, when Transmart start or when the Etrix start, the Spark is quite shippy. But now Spark 2 is almost robust operation engines for in-memory processing. Lots of things can be done. And you have never heard about the machine learning on GPU when we start the project. But these days, TensorFlow is the systems we use daily for the machine learning. Front end changed quite a bit. And also the database, we heard about Neo4j, MongoDB, and when the project starts, it's just at the very early days. And also there are a lot of new things happening, right? About from application server, virtualization in Docker, probably now accepted as a very good way to do the virtualization rather than use the old-fashioned virtual machine. And so all this and message bus is now allowed to reactive programming to make the interaction be very easy. So all this technology is also developed by millions of the computer scientists. So this technology also impact our thinking and development. So we had a lot of options here. And we actually talked, there are a lot of options more than this. This is the option we talk. So we established the Imperial Lab, which is an organization structure to allow research. So not just to produce, but we can do research work. And then under the lab work, we organize the 4 streams. One is the Transmart, and it's work on the foundation closely to build an extendable and a robust system. We have clear goal, right? Sometimes when you're thinking about ourselves, it's really change the gear when you're driving. So in order to do this, you must have a car, at least the robust and extendable. You can have two gears probably. So therefore, you can actually do the job. So Transmart have to be done. So we're working with the foundation to build extendable and robust systems. In the meantime, we devoted efforts to build a quite complete engine to do the study data management, but based on the standard, right? So Paul had a very good presentation this morning on the CDISC, but you need a system to enforce people to use the standard. You need a system to support people to actually enjoy the standard. So this is EHS. So we will talk about this one in detail. And we also, since Spark is so much powerful now, it's quite ready, so we should have a Spark cluster-based analytical engine. So therefore we can deal in the future sort of the full genome and sequencing analysis in a big scale. You cannot really think about this one down by a PC. So we have to research on release map, how we actually present the final result of every single project. Oh, sorry, this is back. No. All right, so I talk about one by one. Then the first one is the transformer development. Our focus is working with the foundation to build a robust core. So the key word is actually robust. So, I mean, we had a 17.1, which they have made a huge contribution to build it. So it's on the along this line is the key function enhancement and robustness of the backend, provided API and quality control of the production deployment, and work close with the foundation. This is very much our goal. So the achievement made is thanks to the great efforts, which particularly the company that made it, is allow the time series analysis, which is really for longitudinal study, and RNA-seq data analysis, samples, cross-study concepts, large file storage, all enhanced in 17.1. And then you actually, very important thing is decomposed the backend with the front end. So because of this, right, the Transmart is become pluggable. This sentence I quoted from the heavy slides. So towards an ecosystem of user interface on the top of Transmart backend. So this is, I think, it's a very, very great achievement. So the Transmart can be a microservice in an ecosystem. The second one is the EHS. I mean, we now have a full system functional and used in the ARMA project, Biologic Safe, and also used in the EIS for integration of UBIPRED and the CODB the project. And this is the really a system which enforce people, support people to use a standard. So if you have a standard, you deliver the templates to the system will create a data input with it based on the standard. And then you can input the data according to this. You can really load the data, curate it against the standard. And then you can see the properties of your study. It's not analysis, it's checking the data quality. You can validate the data with your standard and now get the data ready for next stage analysis. For example, give to the Transmart. So that is the first stage of put it together. There's no concept of what kind of cohort you want to select, nothing, but it's just get the data ready for put into any kind of the data model ontology for analysis. So this is a talk we'll do after me, so I just do the advertisement for you. And then this is the EAE, which is, again, we built. It's a Spark and a GPU-based machine learning analytical engine. So, which dealing with a lot of the, if you like, you can call them low-level work, but actually extremely important to use the GPU and the Spark cluster resource. You don't have too much open source system available for this kind of work. But then what happened to support it, and you have a really good endpoint tools. You can plug into the Transmart systems. But actually one thing which is very, very useful, and we use Jupyter to support actually coding analysis inside the system, just like Mathematica. So that was a really powerful function we added into it. It could be used again as a service to the environment. So this one will be taught by flooring, Kai, and axles after this. So all this doing is we actually now have a function engine which can support the future machine learning. For this is one of the particular projects in Imperial. We use the system AE, plug together with TensorFlow and build something called a tensor base, and which is the model based systems, which you can automatically select different neural network structures for image processing, for medical image, segmentation, annotation, also on. This is all run in a big scale on the big GPU. So now we get to put them together. So the raw system we built. So this is the internal project we call the borderline, and basically define the territory. I was told this is mean that mean, but I don't really know. I think the borderline's good. Sounds very cool. So it's a group to put together each analytic engine, each combination systems, EHS, Transmart, and the other efforts together. But this is really, to provide an environment with also with a wide enriched interface. So people, different user, will have a different choice, use different system for different work, but within an environment. This idea is not new, right? This idea is not new. It's not a surprise. We proposed this one in February 2015. This is the exact picture I copied. The only thing different is we just changed the word, started the prototype by EHS. Apart from that, it's pretty much the same. So, and we call this API backbone as borderline. That's the only thing. So we pretty much delivered what we promised along the way. So this is the borderline architecture. I will not go detail because Florian will have a big talk on this. I don't take his light. So this is really talking about you have a diversity of user types, and different user types may use different systems. And you have a Transmart 7.1 instance, you have EHS. This is for data management, and this is for analysis. And over there, you have the middleware to control using the message systems and to supporting integration of different components here, including analytical engine with EHS, and the reporting engine finally to get the report out. So this is the way you hook the system together to deliver the entire EHS file. So EHS file is for the first time is all the software development in the EHS project put together to serve a purpose, which is precision medicine, of course. So this is the talk, again, they will talk about this, so I'm not going to go into the detail. So by this way, what we want to do is we want to support a diversity of the users in using the systems. For example, for a study, again, this slide is all slides. What I only different, I just changed a different color. And it's, we do exactly the same, this is the only bit I added with the reporting to. So when a project starts, right, you go to where? You go to read your data standard, take the standard, and generate the templates, load data into EHS. So this becomes your project data repository, and this will be a data source of your project. And then you have a Transmart starting working. And then now Transmart will take data based on the problems, analytical problems, and allow you to load the data and into the Transmart to start the cohort selections and start to do the analytical work. But this will join together working with the EHS, AE, because some work could be quite intensive. For example, image processing. For example, in the following talk, is going to talk about whole genome SNP analysis, so on. This could be done in the EAE with the powerful machine learning engine, and then afterwards you report. So this is the EHS file, what it looks like. So we have two words. This is the data management word, this is analytics word. Right? So the data come here, and we're based on the standard, for example, CDisk, right? We have the data templates, we have vocabulary. And then we're taking this one and load data into the combination storage systems. This is your data resource for every project. And then from here, you form ETL to retrieve data, but that's will be very easy to construct it. And almost you can construct automatically because data is standardized. So this is pretty much fixed. For each data standard, you have a structured curation routine to load the data into the transmart. And for the tough job, you will run on the Spark and GPU. That will be the whole structure. And this map will be used as a basic knowledge representation tool, and we work for our future generation of the reporting system. So we have about more than a year to go. If we got extended, I think we will. And so we have now this work started in February. We start to discuss about our extension, and then we started to working on that, and there's a lot of work. But two systems already completed, EHS and EAE at least. The early version has already been used in the projects and in the different organizations. So this is starting to functional and to give us a lot of room to improvement. And then based on this one, we started to design, which takes time, which probably will be end of the July. We were not just working with the each teams. We work with the broad community, with the HAVE, with the foundation, and with all the partners. And we will, and then by close to the end of the year, we'll hopefully, first of all, to integrate with 17.1 to constitute a user interface of the 17.1, and then keep extending it to integrate EAE and finally EHS. And hopefully, by the middle of next year, we can have a full system commission to use. So, and because all the components are there, our major focus is just build the glue, and which Florian will give a detail about how the thing will be glued together. All right, so that is my conclusion. So each slide is a convergence of many software work we have done in the EHS, and from Transmart, from EHS, EAE, and they all constitute a very valuable part of the translational research work. And we aim to have a comprehensive open source platforms for the research. And this is, of course, we will deliver to our founder, to our founder partner, a complete system which we promised, and we should get it done. But also, hopefully, at the birth of the new platform for the field, we really need it. And really need this kind of the system, which Keith already mentioned. It's very, very hard to actually build these kind of things. We spend so much money, so much efforts. We're better to get it done. So let me emphasize again, it's a community effort. It's not just EHS. So in EHS, collaborate with outside, the HAVE and Track Project and the foundations, Harvard group, everybody. And we want to do this one with community efforts beyond EHS in time scale, but also in size. So this is the birth certificate of the whole system. So therefore, it's and actually, I find this very interesting. This is the book cover called Epilogue. Was actually a birth certificate of a new thing, which I think is fit us very well. Okay, thank you very much.